这个是Liquor 3373 maximize the number of target nodes after connecting tree two. For this question, we'll say there is edges one and edges two, which represent two trees, and now what we want is that instead of get a limit k, now what we want is that we want to count those kind of tree nodes which has even distance. So we have tree one, right? Tree one and tree two, and for every time, for example, node zero, right? So still we're thinking doing like the one way, right? For every node, we count how many even number of nodes distance to it, and for two, right, we write similar functions. But the thing is that this one has one optimization is that we don't need to do DFS for every node. And we know that will be O n squared uh, time complexity because we for each node we count those kind of distance. There were this kind of 10 to the power 5 range will be out of time range, right? So what we think about is that instead of DFS or BFS from each node, we'll see for for these nodes, right? We will observe that these kind of nodes, for example, these nodes for the even distance will be this one, right? And also, for example, another one, right? So, so we'll see actually, we'll see this one has how many even counts is one and three, right? Let's look at this one, right? It also has three. That means all of the nodes which it can have only two counts. One count is even is this group, right? Another count is just this group, right? So we just need to DFS once to get a mark. For example, every nodes to be type one or type minus one, right? Just two type of colors. Then we count those kind of colors. For example, one has how many, and two has how many, right? And then from the tree two have the similar operations and mark, right? And for the actually for tree two, we don't for tree one we have interarray to define its colors, and in the end, right, just a check. For example, the node zero is color one, right? So put the values of this count, color one's counts. And for example, node one, this is color minus one, right? Just check this counts, right? And so how can we connect from one tree to another, right? So what we want to connect is that we just want to connect to those uh, those who has it also has small two types of distance. So we connect to those kind of with smaller nodes. Any smaller one, right? Should be fine. So that we left the larger one as an even one, right? So we can so that case is that for these two values we can pick up that greater one to add the result. So let's write code for this. So we are going to have actually I can copy the kind of quick trees. So list of integer tree one equals tree one equals make tree ages one, and the tree two equals make tree ages two, right? Then what we do is that we can write up let's have n equals ages of the length plus one, and m equals ages two of the length plus one, right? And we can mark those kind of nodes into two types colors. For example, we have color one equals new int a, right? And also color two equals new int m, right? But mark those kind of nodes as two different colors. What we want is we just use a DFS, right? DFS and like the tree parity. And we have current node and the current we pick any node, right? Current color is one, and we mark as one and minus one, and color one, right? And also we need DFS tree two, and we pick a color one and the color one, color two, right? Then we're going to have so um, so we are going to have we should get counts, right? So there are only two types of counts. So we're going to have int result one equals get count uh, color one, and int result two equals um, get count color two, right? So for this one, we just get two types of help counts for the color one and the color minus one, right? Minus one. So we'll see. We're going to int max equals max dot max. For result two, we just need to um get two different groups maximum, right? Then we'll have int result equals new int n. Then what we do is set for int I equals 0, I smaller than n, I plus plus, right? So if we'll say if this color I is 1, right? This is the first group. Then we'll have result I equals R1 0 plus in the second group we just add a max, right? Else we just have result equals R1 plus max, right? In the end, just return result. Then we need to write several functions. The make tree function is the first one, right? Private list of all integer make tree, and we need to have ages. So what we do is that int a equals ages dot length plus so on, and what we have create an array is array called tree equals new list and plus so on, right? And the array is set all tree now goes into new array list. Then what it is for array age in ages, then we're going to have a tree E0 add E1, right? And also we need to have E1 add E0. So we need to return this tree, right? Return tree. So this is the make tree, right? And then the part about the mark those kind of nodes into different colors, right? Private void. We can use a DFS, right? So we're going to have passing this kind of integer as tree, uh, tree, and the current color and current node and the current color, right? And also the color array. So the things that color current equals current color, right? Then what is for every int child in tree current? If it's if color doesn't equals zero, we don't need to have parent because it already marked, right? We just continue if color child time equal to 0, we continue. Then we DFS tree and child, and we change the color to be minus color, right? Color. So this will be the DFS to color it. And the get counts will also be simple private int get count, which we have the color array to count into. Actually, we want to int array, right? Int array, which is group um, 1 and group -1. So we're going to have int restart equals new int 2. So for interested in color, if C equals 1, right? So result 0 should increase, else result 1. We should add to result 1, right? And in the end, just return result. This will be the code. So, um, what's in the time complexity, right? So the thing is that because we're just doing the two groups, so just we DFS once. So that will be all m plus in time complexity. And space will also m plus in space complexity. Let's also write Python code for this. So will be very similar, right? So we're going to have um, let's define make tree ages and so um, list all int. So this one return list all int. Okay. And n equals length pages plus 1, right? And then tree equals this one for unstore in range n, right? Then for UV in ages, then we're going to have tree U append V, right? Append V, and also tree V append U, and we just return tree, right? So this is the first one, create tree, and also we need to define DFS. So we have a tree, a list of int, right? So this is a tree. The current node is int. Current color is it is int, can be 1 or -1, right? And the color which is list of int. And for this one, it is white. So what we do is that the color current equals current color, and for child in tree current. So if it's already marked color uh, child down equal to 0, we just need to um, we just need to continue, right? continue. Then what do you do is DFS tree child and minus current color and color. Right? Let's say this one has so this is DFS, and we also need get count, right? Get count. So we need to have color, which is a list of int, which will return an int. Also have a list of int, right? Because we need two groups of count result equals 0, 0. So for in color, what we need is that if C equals 1, right? So result 0 should plus equal to 1, right? Then else result 1 should plus equal to 1, right? In the end, just a return result. So this is get count. Then in our main function, right? We just have tree one, tree two equals make tree age is 1 and make tree age is 2, right? Then what we into n m equals length tree age is 1 plus 1 and length age is 2 plus 1, right? Then we're going to also have color 1 equals this one multiplied by n, and color 2 equals this one multiplied by m. Then DFS 3, 1, 0, 1, color 1, and DFS 3, 2, 0, 1, color 2, right? Then we're going to have R1 equals get count color 1, and R2 equals get count color 2. Then we're going to have max value equals max R2 0 and R2 1. Right? Then we should have result equals this one multiplied by n. For I in range n. Then we check what kind of group it is. If color 1 I equals 1, then result I should equals result 0 plus x, right? Else result I equals result 1, that's 1 plus max weight. And in the end, just return the result.